Today we are going to discuss about SQL Server architecture. Okay, and starting with SQL Server architecture. Actually, what architecture describes about is that what kind of transaction does SQL Server allows, and how the SQL Server will fetch the data from the database when a user requests by using any query, or when a user is trying to search or fetch the data from a database, or when a user is trying to insert the data into the database. We will discuss all about all these internals. What happens when we run a select command, or what happens when we run an insert or update query in the SQL statement. By using these options, uh, mainly the SQL Server runs. If a user is requesting to fetch the data, it is a select statement. And if a user is trying to insert the data, it is an insert statement. And modifications, altering, and all the things are other part. The same part like insert, they comes under. Okay. And while we are considering into the coming into this architecture, SQL Server is having the internal architecture in this way. This is a physical architecture that SQL Server is showing to us, or the Microsoft is describing. What it is saying is that it uses the first, here we are using it as protocols. Here, what we say, what we are using here is that first initially this is called as a protocol layer. What we are saying it here as a protocol layer. This is a protocol layer. Here we are describing it as a protocol layer, and the second layer that which we are seeing here is this all this entire thing is like this is all a relational engine. A relation, how the queries and all the things will happen. This is a storage engine, how the data is stored. All this is described in this process, and this is a relational engine. How the relation is happening, it means like how the query is fetching the data from the database, and what kind of plans it is using, and what is the best plan, or what it does, and actually what does it should do to retrieve the data fastly, and how it should do. All these things are described in this area. This is relational engine, and how the data is stored in the database, this is described in this storage engine. And this is called SQL OS. We are calling it as this part is as SQL OS. What means like operating system, like in a Windows operating system, we are describing it as SQL operating system, nothing more than that. We will go, we'll discuss about all these things in detail. When a user is trying to connect to a database, or to a network, or any other computer, it uses some protocols. The SQL Server uses some protocols to manage that user. If he wants to, it means like it defines some protocols depending upon LAN, WAN, or intranet. Depending upon the protocols, the network differences, it will use some different kind of protocols. And here in this, to establish a connection to the user, it uses some different kinds of protocols. Shared memory, named pipes, and TCP/IP are the protocols that which we are using in SQL Server. What exactly means like a shared memory, or shared memory and TCP/IP named pipes are the protocols that which we are using in our current SQL Server versions. And VIA, it's we used VIA, Virtual Interface Adapter, in the previous versions of SQL Server. We use shared memory. This protocol enables a connection only from that machine. It means like if you're trying to access the data, or if you're trying to connect the domain which is present in your machine, or which is you're trying to connect to the local machine, not like a remote machines. In this case, the shared memory protocol will get enabled. And Next one is like named pipes. It means like when we are in LAN connections, like local area network, like it doesn't mean like internet, intranet, not like internet, intranet. In this kind of connections, SQL Server uses named pipes connections, named pipes protocol. And the third protocol that which we are using is TCP/IP. SQL Server is using TCP/IP protocol. It is the most popular protocol that which we use in our daily life also. It uses a connection from different parts. It doesn't mean like only the same machine or same network. It's like WAN, wide area network. Internet is also likewise internet protocol. This is like internet protocol, IP. This is and virtual. This is deprecated, and we are not using. This is like a huge cables, like some people say, but I'm also not sure that what is it is about. And uh, this is a storage engine in which the data, how the data is stored, and what happens before the data is stored into the disk or a data file. What happens? What is the process is described? What the process? All the process is described in this storage engine, and this is a relational engine. What relation is going to happen to that query when uh, before retrieving the data, and what operations are being performed. This is like SQL OS means how the SQL server is maintaining. If one person connects to database, it's not like a problem. No need of maintenance task. If multiple persons are connecting to the single database, one, two, three, four, five, or multiple purpose, or five-digit members are connecting to a single database, then it becomes uh, what we say, it becomes an efficiency issue. It means that it cannot fetch the data, or it cannot retrieve the information to all these 100 people, 1,000 people at a time. To maintain all these people, SQL Server needs some operating system to maintain those all transactions that queries, or to fetch the data to all the users at a time. Uh, to maintain that, SQL Server is also having some architecture to maintain all the people or all the users if they connect at a time. Multiple users are trying to fetch the data from a single database. In this case, it is using some lock manager, synchronization services, memory manager, worker threads, IO manager, buffer pool. Likewise, we will discuss in this, and this is only just a physical architecture that which we are to have a rough or a brief, not in a elaborated way, to brief to explain you in a brief manner. We are seeing this physical architecture. Okay, let it be. Okay, and this is the diagrammatical representation. The internals we are going to discuss in this architecture. In this architecture, what exactly what is happening, and how the data is how we are fetching the data from the SQL database, from the SQL database. For example, let us consider a person Let us consider a person connected to Amazon. A person is connected to Amazon, is trying to purchase, is trying to order something on Amazon. A person is trying to order something on Amazon to purchase a product or something. Whenever the person trying to connect to the database, that Amazon database, what happens here is that in this case, that that system follows some what happens, the desktop follows some protocols. It means that it will have some a TDS here in the sense tabular data stream. Here we are saying when the user is trying to connect to this database, it follows some it establishes a connection between the what we say, this client machine and the server machine to fetch the data. This user is trying to connect to the database. We need a TDS to establish the connection between uh, the user and client machine. It means the TDS is encapsulated in some with some network packets, which enables the data transfer from a client machine to the server machine. TDS means a data uh, tabular data stream, which was developed by Sybase, but it was now owned by Microsoft. It was not with Sybase now. Uh, just we need to understand the role of TDS is to establish a connection between the client machine and the server machine. When the connection is established between the server machine and the client machine, it uses three protocol layers like it uses a protocol layer to establish a connection between server and client. It means that what we say, it checks, this protocol layer checks what kind of connection this user is having, whether he is into LAN connection, WAN connection, or he is with a single or alone standalone desktop he is having. To identify where he is coming from, this SQL Server is having a network interface called SQL network in a SQL Server network interface, which is having the protocol layer information. In this, we are having three protocol layers: shared memory, named pipes, and TCP/IP. What shared memory will do and what uh, named pipes TCP/IP will do, we have discussed. If not so, we can go far away or deep into this. Here, when we are using a shared memory, means that you are into the local, you are at a local machine. It means like you are just in a local machine. It means you are in a home where you're asking your mother, see here, mom, I need a cup of coffee. It means that she will, here, because you both are at same place, she can listen to you and there is no need of network to communicate in between you. It means that you are in a local machine here. So she will listen to your voice and she will give a coffee. It means that the best example to say is that you are connecting to a SQL server through a local machine. It means that what we will do when we are trying to connect to a local machine in our office or desktop, we'll say, simply we will say 192.168.1.2.101. If not, if it is not in our local machine, or we are connecting to some other domains like Amazon domain, for example, amazon.com slash our username we will be typing. It is like if you are not connecting to local machine, and this is like if you are connecting to a local machine. This is a case where you are not connecting to local machine. In this manner, just to understand this, we are representing, we are displaying it here, and we are having a named pipes. It means like, uh, see, you are in a LAN connection, not in a WAN connection. It means like you're trying to fetch the data from intranet, not internet. We are considering. Means your office desktops are on the same LAN with the same LAN connectivity. Say here, yeah, what Tom is asking, hey Saira, I was thinking to have a green tea. Uh, what Saira is saying, hey Tom, sure, I will prepare and send it in next 10 minutes. Thanks, Saira. I have to study a lot. Your help would help me to sail through. No problem, just wait for 10 more minutes. He can wait because they are on the local machine and they are not at a, not like at same place, but they are with the same connectivity. The LAN is within the same connectivity. They are being able to communicate only with the local machines. Whenever we are having a shared memory protocol, internet shared memory network protocol, there is no need of enabling in SQL Server. You do not require any option to enable that protocol. By default, it will be enabled as shared memory. Whereas if we come to named pipes and TCP/IP, we have to enable it by going into the configuration. See here, network configuration named pipes. We should enable. By default, it will be disabled. Whereas shared pipe will not be by default. It will be enabled because it's like a we are staying at home. And TCP/IP and named pipes are, it's like we are going to different person's home. TCP/IP is like going to crossing our country. We can imagine like we are crossing our country and going. Named pipes is like we are communicating only within our country. Like, and here TCP/IP is like internet connection. The protocol layer is internet connection. You can connect globally or you can communicate with anyone by using their domain name or likewise your access because if they give access to you. This is a TCP/IP protocol. By default, the TCP/IP uses a port number called 1433. It is a default port number, and uh, we can also change this port number if you want by while installing the SQL Server in your desktop. See here, here also it is describing that this protocol connects computers with different hardware and operating system specifications and allows it to communicate together, as it includes a network traffic routing channel. Something he's saying. Okay, this is all about what do we say? This is all about a network protocol layer SNI. Here we are describing it as SNI, SQL Server Network Interface, or a protocol layer of SQL Server. And now that person who is trying to order something in Amazon database is connected to that Amazon database by using one of these three protocol layers. And after that, he is trying to purchase some Samsung or Sony television, and he's trying to fetch the data related to the Samsung or Sony television data, which is present in the Amazon database. When he's trying to take a checkbox of Samsung, what Amazon database will do is it will run a select statement, select Samsung. It will run a select statement, select Samsung. Means that here is using a select operation. The person who is trying to purchase some order is using a select operation. Here is using some select operation. Then what Amazon database will do is that it will his or the person's query is passed to command parser. Here CMD parser is nothing but a command parser. The user query is passed to command parser. Means that the data once received from this protocol layer, it will be transferred to command parser. It will be transferred to command parser. The data that is trying to once received to this protocol layer is transferred to the command parser. This is the first component in the relational database, relational engine. This is all relational engine. Here we have discussed like This is a relational engine, this is a storage engine, and this is a SQL OS. This is the protocol layer we have discussed. The same way here, this is a relational engine, this is a storage engine, and we are having SQL Server OS. We will discuss about SQL Server OS, and here uh, after the protocol connection, protocol layer establishes a connection and data is received to the protocol layer, the data is transferred to the command parser. What command parser will do is that it uses three layers of verification. It uses three layers. It means it do verifications in three steps called as it. It will perform syntax checking, semantic checkings, and later what it will do is that it will throw a query. It will throw a query like what we can say is that we can say command parser in the three phases like uh, it will first do syntax checking, semantic checking, and then it gives it generates a query tree. It generates a query tree to the optimizer by depending upon that. It means here the what we say it generates like some execution tree, not like a query tree. It generates a execution tree and pass it to the optimizer. What it will do is that it does uh, syntax checking. Syntax checking in the sense what we say. For example, if a user is writing, uh, is trying to fetch the data related to Samsung television. Select star from Samsung is a table. It means instead of writing select, the user is trying to fetch the data of sun. Nothing it can be displayed because there is no Samsung television. If not so, each query is like this select. And the computer cannot understand the language because it is not a SQL statement. SCLECR is not a select statement. To do these kind of syntax checking, it uses like syntax checking will be done in the command parser. In the first phase of command parser, syntax checking will be done, and then the semantic checking will be done. Semantic checking in the sense, what we say here we are using Samsung television or select star from Samsung. We are saying select star from Samsung. We are saying it means like the Samsung product is not available in Amazon. Then Samsung spelling is correct here, and the select spelling is correct. Star is correct, from is correct. You are trying to fetch the data from the same Amazon database, but everything is correct. But Amazon is not having or is not selling the product called Samsung. It means that it is no way having the product in the database. It means it will throw an error saying that the product you are trying to search in the database is not available with us. Means what the SQL server will do here is that when a select query when we run when the select query runs, it will do some bindings. It means SQL Server will fetch the data, will try to search for this table, for Samsung table in the Amazon database. If it is there, it will fetch the data to us. If it is not there, it will not fetch the data and it will throw an error saying that we are not selling a Samsung product. It means that the binding happens, fetching the data by searching the same table in inside the SQL server. We are calling it as technically as binding. Data binding happens here to fetch the data in a faster way. Data binding happens here. This is called a semantic checking. And what it will do, finally, it will generate an execution tree and it will pass the same to query optimizer. It will generate a execution tree and it will pass the same query execution tree to the optimizer. Here we can see optimizer. Here what protocol layer will do is that it will combine with the language event by depending upon the collision setting that you have selected while installing the SQL server. If it is likewise what we say, if it is some kind of collision setting that you are using the US English, the SQL server use that. This protocol layer will combine with that language event, and then command parser will select in that language. Command parser most probably will use the same language like SQL server's language only, not like US English or Indian English or Western or UK English. It doesn't mean not like that. Depending upon that collision setting, it will be have SQL server is having some algorithms to check or to differentiate. Nothing more than that to go deeper into the top into that part. And then the command parser, after generating a execution tree with respect to the query that you have executed, select star from Samsung, and then pass the same query to the optimizer. The query here we are calling it as query optimizer. Query optimizer is the most important concept. The query optimizer is the most important component which helps us to retrieve the data from the database or to execute a query that user runs. Here we are saying select star from Samsung means that query optimizer fetches establishes some hundreds of plans so that your data should be fetched in the efficient manner and in a short period of time. It means that query optimizer chooses plans like optimal plan and best plan. Not only two plans, the two different plans I'm saying, but it fetches some hundreds of plans to fetch the query, to fetch the information that user requests in the form of query. It means like here, we can consider an example. One person is trying to go to Dilshuk Nagar from High Tech City. It means he or she may use some different routes to reach Dilshuk Nagar from High Tech City to Dilshuk Nagar. One person may travel by car, one person may travel by road, or one person may use a Ola cab, or one person may use a bicycle, one person may use a scooter or four-wheeler or car, or one person travel a metro. Whatever the mode of plans they are having, the source and destination are same, but the mode of planning in their transportation, in their way of traveling is different here. What the optimizer will do is that what is the best way to reach Dilshuk Nagar from High Tech City. To go Dilshuk Nagar from High Tech City. It means that what the optimizer will do is that it choose the best plan and the efficient plan, and nothing should happen to the person who is trying to reach Dilshuk Nagar from High Tech City. Means what SQL Server will do is that it uses some optimal plan and best plan. Optimal plan and best plan both are different. What the most of the people will be saying, SQL Server uses SQL Server Optimizer uses optimal plan or best plan. It means the difference between the optimal plan and best plan here is that optimal plan is a plan which which a optimizer generates in less than half a second, and the best plan it can take more than 2 to 3 seconds to generate a plan, or the time is not sufficient to generate a best plan, but it will be choosing for the best possibilities to fetch the query, to fetch the information through the query the user requested, what the user has requested in the query. What optimizer is doing is that it calculates the cost of the query, IO resources that the query is using to fetch the data, and the hardware resources and the indexes. What are the indexes that are created on the table that you are trying to fetch the data, and what are the joins or something. It uses it considers all of these options, and then it will uh, estimate the, it will also estimate the row count or row cost, something. Likewise, what here we can see like optimizer, query optimizer. It will SQL Server uses syntax checking, like it is called parsing and finding, and then optimizer. What optimizer will do is that here we can see estimated row counts. It means like we are saying select star from EMP where ENO is less than or equal to 100. It means that how many rows it should count to fetch the user information, and what are the hardware resources we are using, and what is the configuration, query hints, indexes, partitioning, file groups, files, if there are multiple files. Here, optimizer will consider all these information and then fetches a best plan. It means like a optimal plan, not a best plan. Again, don't get confused. In this kind of scenario, while fetching the data, in this scenario, while fetching the data, what query optimizer will do is that it will filter the query plan or the best query plan. It will estimate the best query plan by using in three phases, like phase 0, phase 1, and phase 2. We have a trial plan, transaction processing plan, and parallel processing and optimization. It will do these three kind of checks. In three steps, it will choose the best plan by considering, in these three steps, by considering all these points, it will generate a optimal plan, and the steps involved in considering all these points are these three phases: tribal plan, phase 1, and phase 2. What a tribal plan here we are saying is that a tribal plan means it's nothing but like a user is trying to fetch the data uh, by using a query where optimization is not required, because here we are using select sysdate. It means a system date is generated. Uh, system date is generated without using any optimization plan or optimizing techniques. To fetch the data, to retrieve the user information, or to execute this query completely, we can select. To execute this query, SQL Server doesn't require any kind of optimal plan, optimization technique, or to generate any optimization techniques to execute this query, because it is already system date is already predefined function in the SQL Server. Hence, it doesn't require any kind of optimization techniques to fetch the uh, user requirement, or to fetch the information related to that user query. We can see here. We are trying to see. We will see once. It means like a tribal plans or a plans which doesn't require any optimization plans to execute the query. Select sys date, we are saying. Not sure it will generate or not. System date, or don't know what we can say. Select. See it. Okay. SQL Server doesn't require any kind of optimization technique to fetch this kind of data here. What we can say is, here we are trying to fetch the information of the SQL Server. Select server property. It doesn't require any kind of optimization plans to execute this query, because SQL Server is having the information and it is already a predefined function. Only there is no need of planning in different ways to execute this query and calculating the optimization techniques or optimal plan or best plan to execute this query. SQL Server doesn't require any kind of plans. And what we are saying here is that the next phase that the optimizer is using is transaction processing plan. Transaction processing plan in the sense when a user is trying to fetch the data from multiple tables, it means like select star from employee where ENO is greater than or equal to 100, order by something, order by department number, we are saying. Order by department number or something, we are saying. It means like it is fetching the data by filtering the department column and the employees details whose employee ID is greater than or equal to 100. Just likewise, we are filtering the data. It means like a simple transaction processing plan that's where we use joins, subqueries, or like indexes. Indexes are created on the column. When we are trying to execute a query, on the when we are trying to fetch the data from the table or on the column that we are having some indexes, or when we are trying to fetch the data from multiple tables by using joins or subqueries or inner queries, where clause, having clause. In this case, um, the it means that phase 0 is failed here. Tribal plan is not succeeded because initially phase 1, phase 0 it calculates. Optimizer will check whether it belongs to phase 0, phase 1 or phase 2. It is not a tribal plan. Then the optimizer takes what will do, it will choose phase 1 because it is not a system generated query or a system defined function to choose the tribal plan. Then it will go for a phase 1 like transaction processing plan, where what kind of query it is, and we should use joins or indexes, uh, what we say, what kind of components or constraints that has been that the table the user is trying to access the data from. It means that he is using joins, or is he using uh, or trying to fetch the data from multiple tables by using join, or he is applying any order by clause or where clause or having clause, or he is trying to fetch data from multiple tables, or he is trying to insert the data from one table into another table, like select star into from employee, likewise. In this case, it uses transaction processing plan. If nothing is happening and optimizer is not trying to estimate the optimal plan by using this phase 1 also, then it will go to into this third phase of optimization technique that we are saying here it as parallel processing and optimization. The simple and complex queries are most of the queries, 90 to 95% of the queries are executed by using phase 0 and phase 1. Whatever we say, simple and complex queries are also executed by using the phase 1. But the third phase that which we are having is that parallel processing and optimization. In this phase, what SQL Server will do is that it will have some optimization algorithms. What Microsoft is saying is that it uses some optimization algorithms to fetch the data that has been requested by the user in the form of a query. And that optimization algorithms, Microsoft is not relieving that optimization algorithms. It is keeping in secret. And what Microsoft is saying is that we use some optimization algorithms to fetch the data in any kind of if there is any critical scenario where phase 1 and phase 0 and phase 1 are failing to execute that query. This is all we are happy we can we this is all about query optimizer. What to have a brief or to don't get confused here, what query optimizer will do is that the main role of a query optimizer is to choose an optimal plan so that a user a query should be executed in very less time and in an efficient manner. To execute that query in efficient and optimal, or in a less time, optimizer is using three phases, and in the three phases this optimizer is calculating, estimating the best plans by depending upon this. by calculating all these, what kind of indexes, what kind of configurations, hardware, estimated row counts, by calculating if the table is having table partitions, how many partitions the table is having, and which partition, and in which partition of a table the user query is, the user requested information is stored in which partition. It means that a table is having 10 partitions. If the user query is having his information is stored in the table partition 6, then it will go only into 6. If it is in 5 and 6, it will go only into 5 and 6. To check them, it will also uses partitions, file groups. If a database is having multiple file groups like primary and secondary, likewise, then it will use multiple file groups and files likewise. Uh, like a primary data file and secondary data file, or multiple file groups are created in the table is present in the multiple file groups, then it will use likewise. I think you are clear about the query optimizer, right? Hello, hello.
Bro,
You are clear about query optimizer, right?
yes, yes, yes. Continue,
Okay.
continue.
Yeah, okay. And the next phase of the architecture, that after here we are seeing that Amazon, a person is trying to order something in Amazon database, and he is executing a select query. This person is trying to connect to this from his client machine, client machine to the server machine of Amazon, likewise, and then it uses some TDS per. We require some TDS to establish a connection between client and server machine, which is nothing but as a tabular data stream. To establish a connection between client and server machine, this SNI protocol uses some language event, and then the first layer in the relational database is command parser, which do some semantic and syntax settings, and it will generate the execution query, and it will go to the optimizer. What optimizer will do is that it will generate an optimal query plan. To generate the optimal query plan, we have discussed what all the things optimizer will do. And then after generating an optimal query plan, optimizer will use that query, the best query plan that it has chosen, optimal query plan that it has chosen, and it will give it to query executor to execute the query. To execute the query, it will pass that the efficient query that it has chosen. It will pass the same query to query executor. What query executor will do is that it will give that query, the best query, to access methods. Access methods role is nothing here, and what it will do is that if it is a select command that has been run previously, then it will fetch the data from buffer manager. That buffer manager, if it is already executed the same select query, that query will be present in data cache. It's not like what we say, not like here we are not saying like, it's not like dirty page. It will fetch the data from data cache. It will fetch the data from data cache, because if the query is once executed, that the executed query will be stored in the data cache of SQL Server. We will discuss about what is data cache and why we are calling it data cache and all the things now within 5 minutes. And if the query, if the same select statement that which we are running is select star from Samsung, if it is already been, if it has been already executed previously, then it will fetch the data from data cache, because if it is once executed, that same query, that the query information will be stored in data cache, and what it will do, the same result will be submitted to this person who is trying to access the information, select star from Samsung. In this case, there is no requirement of optimal optimization techniques because it has been already executed. And in this case, it will come. Optimizer will generate best optimal plan, and it will do all the things. But it doesn't require. It doesn't mean that optimizer will not do anything. Optimizer will choose the best plan every time. But to do this, it will not go to anywhere. It will just fetch the data and give the same information to the user that who is accessing the Amazon database. If he is running the same query, select start from Samsung if the query has been executed earlier or before he executed. In that case, what it will do is that it will fetch the data from data cache. The buffer manager will give it to access methods. Access method will give it to query executor. Query executor will will give the same to command parser, and command parser to here and to here. Means finally the same information will be transferred to the user. This is the role of access methods. It means like there is all this. One thing. Just give me 2 minutes. Can we clear with a single option?
Okay, bro. Continue.
Can we clear with single option? Sorry, seeing how to clear all the lessons. Okay, we'll do like this. I'm trying to erase this markings. It will be clear for further explanation. Okay, right, fine. Let it be. Fine, let it be. Okay. And then where we are at access methods. Till now, we are at access methods, and we are at access methods. And what access method is doing is that if it is there, if the query has been run already, if the query is already executed, it will fetch the data from data cache and fetch and give the information to the user that he is trying to access, trying to execute the same query. It is like access methods. And what here we are saying is that if the access method is not trying to fetch the data from data cache because the same query select start from Samsung has not been executed earlier. In this case, what the access methods will do, access method will do is that it will go to transaction manager. Not like transaction manager also, it will not go. It will not go to transaction manager. Sorry. Don't confuse. Or it will not go to transaction manager. What it will do is that it will give the same query to access, it will give the same query to buffer manager, and buffer manager what it will do is it will fetch the data from data file. It is like it is nothing but a hard disk, or here we are saying hard disk, or a disk in which our SQL database is stored. Some people will call as disk, some people will not understand what hard disk is. Totally in SQL terminology, we are calling it as data file, nothing more than that. Here we can say MDF. We are familiar with this word, MDF. And what it will do is, it will fetch the data from MDF and it will give, once the data is fetched from MDF, then it will store the same data in data cache again. And then it will give to the access methods, and then the user gets the information from here again. It is all about a select statement because the user is trying to fetch the database. that is already existing in the database. He is not trying to do anything. The user is just trying to get the information from the database. From the database, uh, the user is trying to get the information uh, from the database, and which is already stored in the database. He is not doing, just he is trying to fetch the information only from the database, which is already existed in the database. Nothing more than that he is doing here. What we can say, and it is all about a select statement if a user runs. And we will see now, he is running a select statement, select star from Samsung. What he is doing is that he's getting the information because the data is already existed in the database. And what happens if the user is trying to, if the customer user is trying to add some rows into the database, or some adding some information into the database, where he will use some insert statement, where he will use some insert statement, we can say like if the user uses some insert statement, we will see now what happens, and what are the internal set are going to happen in the SQL database. There is any insert statement, or we are trying to add some information in the table or something in the database, or anywhere in the database, what it will do is that the same procedure will happen. The for here, protocol checking, command parser, optimizer, and query executor access methods. Up to here, the scenario will be same. The optimizer will choose the best plan to insert that statement, and something will happen. After this, because the data is not in the data file or disk, he is trying to add some additional information into the database. He cannot retrieve the data from data cache or from data file. What access method will do is that if it is an insert statement, it will go to transaction manager. Now, in transaction manager, we are having two kind of files, like two kind of components, like log manager and log manager. Actually, we need to discuss one thing before this insert statement. Whatever the transaction that SQL server will do, it should follow some properties like what we say, ACID properties. SQL server should follow some ACID properties like what we say. It is a rule of SQL Server database to have these properties. The SQL Server transaction should follow the properties like ACID, where here we are calling is A stands for atomicity. Atomicity is like what we can say means, we can also consider here like a best example, like in chemistry we are having some compounds, or a water, we can consider water as an example. What water will have the molecules, water molecules will be present in that, and we are having some H2O, we are calling hydrogen, two molecules of hydrogen and one molecule of oxygen. Combinedly, we are calling it as water. These these both molecules are combinedly saying here we are considering it as a water molecule. Means if there is no O, it is not considered as water. If there is no H or hydrogen, it is not considered as water. It means that H2O is losing its characteristics without O or without H. both are mandate here to have the molecules inside, and after having the both components or both molecules only, it is considered as water. In the same way, what we are saying is that atomic means, what we are saying here is that we can also describe in a SQL Server terminology, we are calling it as all the statements that we are trying to execute, all the statements at which we are trying to execute in SQL Server, all the statements should be committed or none of the statements should be committed. Means like if O fails, it is not called as water. If H fails, S molecule fails, it is not called as water. It means we are trying to write 3 to 4 statements in a single query. It means insert into, insert into, insert into. Four inserts we are doing into single statement. It means if the third statement fails also, it will not execute. If the fourth statement fails also, it will not execute. It means we are saying either all of the statements should get executed or none of the statement would executed. Then only your query will execute completely. Here we are saying the second component here we are calling it as second rule we are calling it consistent or consistency. What consistency in the sense here we can say, for example, if a person enters into a bank and he's trying to do some cash deposit into the bank, he deposits the cash and the cashier in the bank took money and he entered. He entered some saying that some so and so ABC XYZ 1234 account number has been deposited some 10,000 rupees Indian currency into this bank into his account number, and he press enter, and after he pressing and confirming the details after 5 minutes, what happens to the bank is that server disaster occur. It means that uh, the information should be stored in the server even if the disaster occurs. It means like if the sufficient information or proper information has been entered into the server or into the database, it should not take. It means even if the disaster occurs also, the roll forward or roll backward should happen. Nothing must happen to that customer. The disaster happens to your server. There should be some guarantee. Here we can say in a single word, there should be some guarantee. Here atomicity is nothing but all the statements should get executed or none of the statements should executed. Consistency is but nothing but we should have some guarantee. And the next thing that the property is describing is I stands for isolation. Isolation in the sense if multiple customers are standing in a line in front of the cashier in the bank, one customer should not disturb the other. Everyone has to should do their own activity. It means like what we say. Let us consider the same example as Amazon. Multiple customers are trying to purchase a Samsung television, same Samsung television, which is present in the Amazon database. Then one person's transaction or retrieving the price of the Samsung TV should not affect the other person. There should be some security layer protocols. It means that what SQL Server will do is that in the same millisecond or nanosecond, the select star from Samsung is executed. It is, until the query gets executed, what SQL Server will do is that it will place a lock on the table, and the query execution completes by the user. Then it will automatically releases a lock, so that the other user can execute the same query. This is called isolation. It means one should not get disturbed by other. The person, if a person A is trying to fetch the data from Samsung table, and at the same point of time, another person is trying to fetch the data from same table, while the person A is trying to execute the fetch the data from Samsung table only, it places a lock on that. SQL Server places a lock on that Samsung table, and after the completion, query execution completed by a person A, then it releases lock, and then after a person B can fetch the data from the same table. It means like person A is not disturbing the person B, and person B is not disturbing the person C. Everyone will fetch the data or information from the same table parallelly or simultaneously, we can say. Not like simultaneously, parallelly, we can say. And the fourth letter is describing is that durability. Durability in the sense, if a person deposited a cash in the bank and cashier entered that there's something, a person with some product name or product ID like a bank account number deposited cash, and he pressed enter so that the server is committed the information. Once once the information committed, it should not be rolled back, it should not be deleted without any proper admin rights. It means that violation should not happen. What we can call, what we can say, the same statement in SQL terminology or in the technical terminology is that the data once committed, it cannot be rolled back. Only with appropriate permissions or it can be deleted. This is called, these are called ACID properties. Whenever any transaction or any statement or anything happen, any transaction that happens in the database, if these ACID properties are not satisfying, SQL server will not allow, SQL database or SQL server will not allow the transaction to happen if any of the condition fails. Are you clear about these ACID properties? Atomicity, consistency, isolation, and durability. Hello.
Yes, bro. Yes.
Yes.
Yes. Yes.
Okay. Then we will go to the next slide or next thing. Here we are access methods. Here we are having access methods. What access method is doing when we are trying to insert data, the transaction, because the due to this transaction word only we move there to to have a discussion about the transaction. What happens? What SQL Server transaction means. Transaction manager will do will have two components like log manager and log manager. What log manager will do is that it will take the data. It will take the data from the access methods that the user is trying to insert. Then it will keep it into the transaction log file. Here we are calling this transaction log file. It will keep the data in the transaction log file. And what transaction log file will do is that here we are having a component called a checkpoint. Here we are having a component called checkpoint here. Whenever a checkpoint occurs, all the data inserted by the user or multiple users or single user, whenever a checkpoint occurs, all the data that is present in this transaction log file will get truncated. It means that transaction log file becomes empty. When the checkpoint runs, the transaction log file becomes empty. It doesn't mean like empty. It will truncate the data that is present in the transaction log file, and that it is moved to the data file. It is not directly moved to the data file. It will give the data to transaction manager, to access methods. Access methods will pass the same transaction log file information to this data file. Not transaction log file never give the data or transfers the file information that is present in the transaction log file to data file directly. This is most important point that we need to remember here. And we will see how the checkpoint runs and in what cases the checkpoint runs. We will see now within 5 minutes. Transaction log file will not, whenever checkpoint occurs, the transaction log file gets truncated, and the transaction log information that is present in the transaction log file move to the data file through these components: access method, buffer manager, and data file components. A checkpoint, what we can say is that to minimize the load in the transaction log file, SQL Server internally using a component called checkpoint, which runs for every second from SQL Server 2012 edition and version, and before it is for every 5 seconds. We can also modify the timings to run a checkpoint. We are having some sys sp configure recovery time interval, 5 seconds, 10 seconds. We can also modify the checkpoint timings to execute internally. We are also having 4 types of checkpoints like internal checkpoint, manual checkpoint, indirect checkpoint, and automatic checkpoint. We will discuss about all these types of checkpoints in our later sessions. After 2 to 3 sessions, we'll come to that class. We'll come to that session checkpoint, and then transaction log file. When the transaction log file gets truncated, the data is moved from transaction log file to the data file. Now, if a user if a user is trying to select the data that what the insert has been committed into the data file, then the select statement will work for that information that has been stored in the database with respect to that transaction. This is the role of transaction log file. It is having 2 components, log file and log file. We discussed about log manager and log manager. We discussed about log manager because log manager only, here what log manager will do is it will generate a LSN. What log manager will do is it will generate a LSN for each and every transaction that has been done in the SQL server. It will generate a LSN for each and every transaction. LSN will be unique for each and every transaction in the SQL server database. So then the transaction ID will be appropriate. What they will do when we go and deposit a bank, when we go and deposit the money in the bank, after on the deposit statement, what the cashier will do is that he will stamp on the paper or a receipt and he will write some transaction ID. I think you are aware of that. Likewise, to maintain some uniqueness, what SQL Server will do is it will generate a LSN to each and every transaction that is happening in the database, that happens in the database. That is the duty of it is the responsibility of log manager, not log manager, log manager to generate a LSN. To generate a LSN for each and every transaction that happens in the database, and the log manager only invokes the checkpoint to truncate the log file. It means here you are having 2 responsibilities, 2 roles that log manager is taking care of: generating a LSN and truncating the log files. And what log manager will do is that whenever we just now discussed that a select statement has been running, select the same select statement, select start from EMP is a person A is trying to select select a query, select start from EMP, and then lock occurs on that table. After the query execution completed by the person A and fetches the data, then until that time, the lock manager will apply a lock on that. Here we are saying lock manager. Lock manager will apply a lock on the table. It is a duty of a lock manager. It means that to maintain some security, isolation. It means that isolation property is satisfying here. Isolation means one person should not get disturbed by other. Due to that, lock manager will apply locks. And locks are of different types. It is another session we will discuss in our further classes. And transaction log is having 2 components: log manager and log manager. When the insert is happening, the transaction manager inserts the data into transaction log file, and after truncating the log file, after checkpoint truncating the log file, that insert statement is committed now. If it is moved into the data file, then it's committed. It doesn't mean like if transaction log file, if the data is insert statement is stored in the transaction log file, and if the disaster happens, it doesn't mean that there is no data loss. The transaction log file remains same, and after the disaster, after the server coming into online, we can truncate the log file again. Before the disaster happens, only checkpoints. SQL Server runs checkpoints internally. Before the server is shutting down, only checkpoint will run internally. SQL Server will run the checkpoint internally, and at that point of time, the log file get truncated and the data is stored in the data file. If something happens and it does not, the transaction log file not get truncated, there is no option that transaction log file will not get truncated and the server will go into disaster. there is any case like a log file full, it means the data that you are storing D drive, or if there is no disk space, in that cases the transaction log file will not get truncated. But in that case, the database will go into suspect mode. We are having some possibilities to recover the data and to move the data into data file from the log file after the SQL server coming into online. Now from suspect state to online state, nothing happens. There is no data loss here. We should not think of think of a point like data loss here in this kind of scenario. You may get a doubt like this. To clarify you, I'm just explaining. We will not go deeper into that now. Okay. This is all about insert statement that which we are discussing now. What insert statement is doing is it will come to the access methods directly from here and the transaction manager, and it will go to log file, and log file will throw that information, will store that information into the data file. It is all about an insert statement, and we have discussed now. It's all like whenever we have just discussed, like whenever we run a select statement and the select statement is already executed, and in that case the user gets a data from data cache if the select statement that has been already executed. It means if any query that has been executed earlier, that the data is stored in this data cache, and the user gets the information in this from this data cache. Either it might be select statement. If the user is trying to retrieve the data, then it is obviously a select statement, because it will not go to data file, log file or something. It will not go anywhere directly. It fetches the data from data cache. But how long this data is stored in the data cache? We need to consider this point. Before going to that point, we will discuss something about. Here we are saying that after the insert is happening, access methods, it will pass the data, pass that information to transaction manager and to transaction log file. After transaction log file getting truncated, means that after the checkpoint runs, transaction log file gets truncated, and the same information is passed to transaction manager, access methods, and buffer manager, and to data cache, and from there here to data file, the data will go. In this case, if the transaction that has been if the transaction log file gets truncated, and then it has been passed this information to this data cache but not stored in the data page, what we can say in the data file, those pages are considered as dirty pages. It means that the data that has been inserted into the transaction log file but has been not committed to the data file. The data is not committed to the data file but moved from transaction log file to data cache. Those pages we are calling it as dirty pages. Sometimes if there is any user trying to fetch the data, the data that has been not moved to the data file and that is present in the dirty page, the user gets the information from it here itself, and it will not go to data file now. These data pages are what we say. Here also we can consider how long these dirty pages will remain same without moving to data file. Means that how much time? It means for 5 minutes or 10 minutes, the dirty pages will be stored in the data cache. What we can say here is that it uses a component called what SQL Server uses like a PLE. It means that page life expectancy, or it uses some component called LRU algorithm, lazy writer. What we say? A lazy writer is a component, lazy writer. Here we are having a component called lazy writer. What lazy writer will do is that what this lazy writer will do is that it will lazy writer will Sorry for the decision. What lazy writer will do is that it will it will follow some algorithm like LRU. What do you say? LRU algorithm. It means that least recently used algorithm. It means that out of all these dirty pages, what is the least recently used page by the user to fetch the data from this data cache? What it will do is that it will filter that the least recently used pages, and then it will move that those pages to this data cache. Then these dirty pages becomes a clean page now. In this scenario, this dirty page becomes a clean page. It means that the data that is present in these pages is moved to the data file, and in this case, we are calling all these dirty pages or clean page. What kind of scenarios a lazy writer invokes? We need to consider this point. In what kind of scenarios the lazy writer will come into picture? We have to consider this scenario now, because what we can say at in what situations the lazy writer will get invoked to move the dirty to change the dirty pages into clean pages. What kind of scenarios that a lazy writer comes into picture? In what cases? We will see now. This what the data cache uses is data cache uses some what SQL Server is saying is that it uses some uh, sorry. It uses some PLE technique, page life expectancy and memory pressure. Memory pressure it uses. Page life expectancy in the sense SQL Server internally decides how much time. Means that depending upon the size of your database, or depending upon the pages that are SQL Server is writing within a particular span of time in a regular interval, depending upon that inflow transactions. It means like OLTP transactions. Depending upon the transaction that we are having in the database, it will estimate some page life expectancy. Means the minimum page life expectancy that SQL Server is saying is 300 seconds. It means until 5 minutes, the dirty pages will not become clean page. But if is there any case that lazy writer invokes below these 5 minutes, those dirty pages will be converted to clean page. But until then, it will not connect. It will not. The dirty pages are not going to convert as a clean page. It means that the dirty pages are not being written to the data file. If there is any scenario that more than 5 minutes that the lazy writer is not getting invoked, in that case, page life expectancy comes into picture. But the page life expectancy will not be the 300 seconds for every database. It depends upon the size of pages or size of the database that which we are having. The minimum Microsoft is saying is that the minimum page life expectancy is that 300 seconds. Only in the case that the lazy writer does not get invoked. If the lazy writer gets invoked, there is no chance that the pages should remains in the data cache until 300 seconds. It is no guarantee that the lazy writer does not get invoked. Only PLE comes into picture, page life expectancy comes into picture, and then after that 300 seconds, it means that minimum 300 seconds Microsoft is suggesting. Buffer manager decides what is the page life expectancy of the database. It may differ from database to database. Buffer manager decides what is the page life expectancy of the database. I will show that what is the page life expectancy, and there we can see in the database also. At that particular point of time, it means that after 5 minutes, if the lazy writer does not get invoked, the dirty pages will become clean page by moving the dirty pages into the data file. This thing happens here. page life expectancy comes into the picture and then converts the data pages into clean page here. And memory pressure. If there is any memory pressure, to this data cache or buffer pool, then at that point of time also the dirty pages will convert into a clean page. It means that the data will, the dirty pages will be moved to the data file, and then the clean pages will be here. After that, if the pages are clean here, the insert transactions or the transactions that are being happened in the database will be written here. In that, it means that we need to have a faster conversion from dirty to clean, dirty to clean, dirty to clean, dirty to clean, like this. So, and we will discuss about buffer pool here in detail. Wait, yeah. What here we are saying is that buffer manager. What actually happens is that whenever SQL Server is allocated with some 64 GB of memory RAM, what buffer manager will do is that buffer pool. What SQL Server will do, if your desktop is having 64 GB of RAM and uh, you are installing SQL Server in the desktop, what SQL Server it will do is that it will use 80%, 85% of RAM. Maximum it uses 85% of RAM is allocated to the SQL Server, and 15% of RAM will be allocated to your Windows operating system or any other resources that you are running on your desktop. In that 85%, it means like you are having 100 GB of RAM, 85 GB of RAM is allocated to SQL Server, and 15% to your additional resources that you are trying to operate on your desktop. In that 85% of RAM, mem to live, here we are having mem to live option, mem to live, it means that memory to live, here we are saying 384 MB, 384 MB, internally minimum of 384 MB, mem to live will reserve out of that 85 GB. Out of that 85 GB, 384 will be allocated to mem to live, and the remaining will be allocated to SQL Server. What mem to live here? You can ask what MTL means. Mem to live. This 384 MB, it doesn't mean like only 384 MB. It is like minimum 384 MB. Microsoft is saying, and it may varies depending upon the linked servers that you have created and the existing threads you are having on SQL Server. Memory consumed by memory class. It means like a memory pressure. We can say memory request, DBmail configuration, all like we can say extended store procedures, means XP. We will fetch the data from outside of SQL Server. XP underscore read error log. It means the data is not present in SQL Server, but it is present on D drive or E drive on your desktop. Extended store procedures, linked servers or objects. To do all these activities, MTL consumes 384 MB minimum, Microsoft is saying, and it will increase depending upon the situation. And bpool means, here we are calling it nothing. Bpool is nothing but here we are calling it as a buffer pool, nothing more than that. All the memory is allocated to buffer pool, which manages all these activities. It means like every transaction is happening here. We are not saying nothing. These are all not doing anything. Every transaction is happening, but finally the data is being stored in data cache or data file or buffer pool. What we say buffer pool initially. Data file is like, which is where here we are storing in our desktop. It means like some in E drive we will have MDF. The data is stored in desktop. But with respect to SQL, here buffer pool is a data. A buffer pool is the disk here with respect to SQL. But after committing or data is getting committed, the data is stored in a drive. That physical, what do you say? That hard drive. Physically, we are storing the data in hard drive physically. Until then, the data should be stored here in buffer pool or data cache. Here we are saying. What does plan cache means? If there is any query plan that has been already executed, all the query plans that has been already executed will be stored in this plan cache, data cache, and log cache also you will be having. What the log cache will do is that What log cache means? Before information is going to into the log file, the data will be present in the log cache, just like before the data is going into the data cache. Before the information is going into the log file, the data will be present in the log cache. It is like another deep dive. Here you will be having a write log wait type like this. Yeah, that much internal we do not require. It is like in the architecture level. That is a deep dive. We do not require that much. Where we are here soft parsing means that soft parsing is nothing but it is not like anything that we are not aware till now. We are aware of this. There is any query that has been executed by the user, and that query is information. That query information is retrieved to the user from the data cache. Then that kind of parsing we are calling it as soft parsing, and the same information that has been brought from the data file, it means that the query is not present in the data cache. Then it means that we are calling it as hard parsing. Simply we can consider it here as the user is trying to fetch the data from data cache, then it is soft parsing. If the user is trying to fetch the data from data file or disk, then it is called as hard parsing, nothing more than that. We have covered all the things, but we have to cover SQL OS here. What SQL OS will do is that, what is the role of SQL operating system here? We will discuss. SQL operating system will generate some, here we still know we have considered only one person is trying to access Amazon website. What happens if there are multiple people or multiple persons trying to access the same Amazon database, Amazon.com, at a single point of time? At the same point of time, not a single point, at the same point of time. It means that in that case, SQL should be capable to handle multiple persons' requests. It means that it should have some memory pressures. It should have some memory manager to what we say, to control that pressures. It should have some memory manager to control that pressure. In this case, what SQL Server is doing is that, it means like what do we say, the CPU, our CPU in this case, what CPU will do is that we all know that CPU CPU will have scheduler. What SQL Server will do is that scheduler, we can say here. What SQL Server will do is that if there are multiple persons, it means like P1, P2, multiple persons are see, what CPU is having here, having a scheduler. If there are multiple persons, they are trying to, this P1 is trying to, this P1 is also trying to, this P1 is also trying to fetch the data from Amazon database, and then P2 is also trying to fetch the data from Amazon database, and then P2 is also trying to fetch the data from the same Amazon database. Here we are saying that Amazon, you can say Amazon.com or something. P1 is trying to fetch the data, P2 is also trying to fetch the data, whereas P3 is also trying to fetch the data. In this case, what SQL Server will do is that for each and every transaction, P1 is doing one transaction, sorry, it will generate one thread here. it will generate one thread 1, thread 2, thread 3. And the scheduler manages all these threads requested raised by multiple persons. Means like what we can say is that until until the T1 transaction gets completed, uh, if the T1 is executing in the transaction P1, it means that the P1 a person is trying to execute a transaction. It means that his transaction being executed, then he will be in a runnable state. And P2 is trying to execute but not executed. He is trying to execute. Then he will be in what we can say is that runnable state and suspended state, because he should wait uh, until that transaction gets completed. You should wait. Likewise, we are having running state, runnable state, suspended state, and these three states we are having. It means that if the query is being executed, then it is called a running state, and the query is in wait to execute, then it is called a runnable state, and the query is waiting to execute. It means that it is not being coming into existence. To execute also it is not being coming. It is still in a row. Then it is called suspended state. We will be going into this deeper in our later sessions in performance tuning concepts. And what we need to consider, we have missed. Yes, what we have to discuss here is data file. Means data file is again a combination of file groups and files. Here we are saying extensive means like a 8 KB size of page is called 8 KB size of content here in SQL Server is called as page, one page. And if these pages are 8, and then here we are calling it as extended. Here a data file may have file groups, different file groups, and we are having multiple data files also, like not multiple. One metadata file, log data file. A database is a combination of MDF and NDF, LDF. MDF and LDF we know, and in some cases we also create secondary data files. We will discuss about this in our next class or in our upcoming sessions. We are having one session, complete session with respect to this data file concept, data file architecture. We will discuss like pages concept, page concept completely. Uh, Again, it's another lengthy topic, another session. And after all these, we need to have some. You will be aware of this with respect to this database architecture, SQL Server architecture. Out of this complete session, you should be capable to answer these questions that which we are having on the slide, like what are the three types of protocol, sorry, what are the three types of protocol that we are using here. I need cursor now. Okay, what are the three types of protocols that which we are using here to connect to establish a connection? CMD parser, what is the role of CMD parser? Query optimizer, ACID properties, buffer manager, MTL, mem2do, plan cache, log cache, 30 pages, PLE, page life expectancy, LRU algorithm, least recently used algorithm, memory pressure, soft parsing, hard parsing, log manager, log manager. We have missed this point, right ahead logging. I will show you what is the right ahead logging. I'll explain this. Now here we will see right ahead logging, in the sense whenever access methods is trying to insert the data into the transaction log file with the help of transaction manager, the transaction log file is getting updated here. It means that additional information is being written to the transaction log file. That process we are calling it as a right ahead logging. Right ahead logging. And we have to, nothing more than that we can see here. We have to see the page life expectancy, right? Database. some reports like let's see, it's our level. No, reports. So it's not connected actually. See here. This is page life expectancy. Here we are having, this is 43. Here we are having something like might be it is in not be 43. We'll see for database weight. Will not have for database. Consumption will not have for database. 16 is like 43. So report provides detailed data on the memory consumption of components in instance, like it might be it is in minutes. It should not be like in it will always be in seconds. I will go through this point and I will update you on this. It should be in seconds only. The minimum is 300 that Microsoft is saying. We will discuss about this. Anything that anything information that you did not gather or you did not understand here? Hello, hello.
Hello?
Anything is
Hello?
yeah. Anything that
Yeah.
you're having any doubts or anything?
No, everything is okay. I have a small doubt.
Yeah.
Like for isolation,
Mm.
for isolation,
Mm.
uh,
Acid property.
e- yes,
Yeah.
asset property for isolation.
Mm.
If multiple customers give a query for at a time, then how it
Okay.
is possible?
Yes. In that case only, let us consider an example. Select the star from employee table or EMP you are running.
Yes.
Select star from EMP.
Hmm.
It takes some fraction of seconds to execute that query. If you are running that query, it takes some fraction of seconds. It means like 3 seconds. It will not take
Uh-huh.
sir,
Bro,
two
bro, listen,
seconds.
listen,
Yeah.
listen. My doubt is,
Mm.
uh, if you have launched a new product, okay, like phone
Okay.
or something, okay,
Okay. Okay.
uh, ten
Samsung
thousand custom,
M30s is added into Amazon
uh,
database.
yes, database, okay,
Okay. Mm.
uh, 5,000 customers will click that button at a time, like search will search like at a time. Then
Yes.
how it
Yes.
then
I
how
will
it is
explain you
possible?
here. Yes. Yes. I'm coming to you. Person A is trying to is pressing submit button. It's like select
Hmm.
star from EMB is running. It
Hmm.
takes 2 seconds or fraction of second,
Fraction of seconds.
milliseconds,
Okay.
milliseconds
Okay. Hmm.
to fetch the data. Until that
Hmm.
milliseconds, what for all the other 4,999%, what
Hmm.
happens is that buffering happens on the database. It means that query is still executing.
Hmm. Hmm. Hmm.
They are on runnable state, not in running state. They
Okay.
are on
Okay.
runnable state.
Okay. Okay. Okay.
It means that
If
query
if if the
executing, query
if the
processing.
image is displayed,
Hmm.
then the state will be runnable,
It's
right?
running state. Already happened now.
Running.
Running
Yeah. Okay.
state.
Okay. Running state. Running. Sorry.
Running.
Sorry. Running state. If the
Running,
data
runnable
is
and
not fetching,
suspended.
if the data is not fetching, then it will be suspended state.
Yes, the query processing is also not showing on your screen. It means that
Yes.
buffering is also not showing on your screen. Then they are in suspended state.
Suspended state. Okay.
Yes.
That's my doubt. That's
There I did some confusion to you some regarding running and runnable state. Then I gave you some clear concept. You also asked the same
Yeah,
doubt.
yeah,
Yes.
yeah, yeah. Okay, bro. Thank you, bro.
Yeah. I'll what I'll do. It's fine now. Up to
Yes,
any
yes.
doubts?